Let's check the working procedure of the statement machine. Its mode is melee and the code description type is 3 process. When the reset is 1, C state is set to idle name 001. In the schematic, we found C state register 0 is FDPE. Other registers are FDCE. Thus, C state register 0 is 1, other registers are 0 and this time. At the 18th nanosecond, we start inserting one coin. Here, one thing needs to be clarified. We are only concerned about the state machine. In practice, insert coin needs to be first synchronized in order to insert coin matches the actual situation. Here, we are receive the insert coin value and don't care about other things, such as metastability and coin counting mistakes. Let's go on. In the combinational logic, as insert coin is set to 1, the process goes into the case branch of C state. At this moment, C state is idle status. Next state is set to 1. Let's see what happened to this process in the schematic. The reason that next status is not displayed is next status is optimized away. 2 process and 3 process both are synthesized as the same schematic. Because reset is still 1, all FDCE will maintain 0, FDPE will maintain 1. At the 51st nanosecond, reset is set to 0. Since insert coin and C state have no change, they all will maintain the previous status. At the 70 nanosecond, current state is assigned as next state, namely 010. Turn to the schematic, the clock is at the rising edge. All registers are working now. In the current state 0 loot, L0 is 1, L1 is 0, L2 is 1, L3 is 0. Its output value is 0 according to the truth table below. In the current state 1 loot, L0 is 1, L1 is 0, L2 is 0, L3 is 1. Its output value is 1 according to the truth table below. In the current state 2 loot, L0 is 1, L1 is 0, L2 is 1, L3 is 0. Its output value is 0 according to the truth table below. Thus, current state is 010 at this moment. Next state is set to 100 and current state is set. At the 85th nanosecond, next state is set to 010. As insert coin is set to 0. Turn to the schematic. Even though insert coin is set to 0, since clock is not at the rising edge, all the registers remain in the previous status. At the 90 nanosecond, current state maintains 010 since next state has been set to 010. It is similar to that at the 70 nanosecond in the schematic. We just need to check the loot table to know their output value. Here I will not repeat. At the 98th nanosecond, next state is set to 100 and insert coin is set to 1. At the 110th nanosecond, first, current state assigned the value of next state, namely 100. Then, next state is set to 001 and current state changes. At the 130th nanosecond, first, current state assigned the value of next state, namely 001. Next state is set to 010 and current state changes. Then beverage is set to 1 at the moment. Since current state is using non-blocking assignment, current state is still 100 at the present. Turn to the schematic. In the beverage 0 loot, L0 is 0. L1 is 0, L2 is 1, L3 is 1. Its output is set to 1. Then the beverage register output will be 1. That's all for today's video.